Alright, so I just optimized stuff like shortly, and let me turn on the lights. It's dark. It's really dark inside here. Alright, so let's see. Yeah, that's perfect. Alright, so now that I've optimized my title so that I feel like I'm not wasting my time, or rather, like, I already did the problem, but you know, it's way easier to... Oh wait, I think hello? Yeah. Hey everyone. Yeah, so it's way easier to talk when... I know that I've like done everything right, you know? That, hey, if I could have gotten anyone in the stream, then I have gotten them in the stream. So now I'm just going to, get started with everything. Let me just get started with everything right now. Hey everyone, if you just joined, welcome. I am just like setting up one thing and getting started. So let's see this. Okay. Actually, could have done that before. Either way, welcome everyone again. So I'll just keep this short. I'll just keep the intro a bit short. What we're going to be doing right now is taking a look at LeetCode 46 and LeetCode 46. Let's just read the description of it. The name of the problem is permutations. So given an array nums of unique integers, return all the possible permutations. You may return the answer in any order. So if we look at the input, nums 1, 2, 3, and the output is every permutation of this input. So let's see, how did I go about like solving this? So yesterday I had like an incredibly hard time in stream trying to solve this problem, but I did actually more or less solve it with this solution over here. But one thing that you'll notice, and that we'll see in a moment, actually, I don't know which one is solutions. By the way, I'm on LeetCode.io. That's the site that I'm using. I usually use it before I move over to LeetCode because the problems the test cases are a bit easier. So I can validate what I've done first before trying for like more difficult test cases. Anyway, so this is where we start, and as you see, we're actually wrong. And we can see over here that our output is just like these empty arrays over here. So the question we may ask ourselves, and which is relevant to us, is of course like, hey, what are we doing wrong? And can you also see my screen? What are we doing wrong? So I'm just going to post that question in the chat for a moment and give you all like a moment to answer this. What are we doing wrong? Where is the bug? Alright. I hope y'all are doing well today. down. I'm on screen. Hey guys. Yeah, I hope you had fun watching a disembodied. I'm not a disembodied head, but just no head talking to you all. Let's see. I'm just inspecting my screen for. I see. Hey guys, welcome. So they were checking out LeetCode 46 and. Yeah, so yesterday we looked at this problem, but we had a bug in it. So on stream, I actually had like a very difficult time trying to solve this. But the problem in itself is and we go over. So what we do here is this. You'll see that we actually have a bug. So let's just run this. And we'll see that it doesn't work. And if we inspect like the output that we get over here, we can see that we have these empty arrays over here. So there's a bug over here, and it's a really sneaky bug because the code mostly looks right. And I'll tell you. So let's go over the code. Let's go over like the different steps and how I came to this solution. So the problem that we're dealing with, just to give a short summary, is the permutations problem. And this problem says, given an array nums of unique integers, return all the possible permutations. You may return the answer in any order. All right? So what we can tell over here is if we have so what we can say is that if we so usually if we wanted to get the solution to this or all the permutations, we actually have a Python function for that. In iter tools there's combinations, the combinatoric iterators, and there's combinations and there's also permutations. So usually, we just do this, but the whole point of this problem, of course, is for us to find the actual, quote unquote, the actual solution to it, which isn't just using some inbuilt functions. So what we need over here, 100% is going to be some form of recursion. So in recursion, what's recursion? Recursion is basically having a function call itself. And that's what we see over here. You see, we do define this function called traverse, and we call traverse within traverse over here. So let's go through an example just so we can understand what is going on in this function. And let's go through this example over here. We have our array, our list that has the numbers 1, 2, 3. So what happens is, we come here and we traverse the function. And when we call the function traverse, we enter the list, we enter the function with nums being 1, 2, 3. And at this point, is when all the magic happens. So for each number in this array, we'll enumerate over them. So we'll go over each of them one by one. And first we check if skip indexes of num equals to if skip indexes num equals to true, then we just pass. We go to the next number. So what is the idea behind this? Well, we'll see it in a moment. I'll just go over this first. Next, we have we are at this point where we say stack.append num. So if we hadn't seen it before, we append it. And then next we set skip indexes to true, and we call the function traverse. And once we're done with that, we pop and we set skip indexes to false. So let's take a look at this. How does this look? And the best way to look at this is through a tree. And let this list that we have over here be our stack. So initially we add 1 to the stack because scene is a default dict. our skip indexes is a default dict, which we initialize with the constructor bool. And basically, if in Python, if we say, sorry, just a moment, let me add the window capture for that. In Python, just a second, guys. Oh yeah, I did have that issue recently. Sorry guys, I just need to fix something real quick. Okay. I can't really. All right, great. So, where was I? I just wanted to show you on my screen. So let's see, display capture, I guess. Okay. Sorry, just config stuff at the moment. Okay. I see the problem. Okay. So anyway, let me just introduce this right now. Okay. So the problem that we had basically is the following over here. That let's clear this over here. All right. So what did I want to show you all again? Oh yeah, let me just show you all this. And what did I want to show you all again? I'm so sorry, guys. I just completely forgotten after where I was after all of this. So exactly, I was explaining this part over here. Yes. Anyway, so I'll just go on with this explanation. We have this list, and we are basically going to Yeah, so initially we start and we add 1 to the list. Aha, all right, I remember. So in Python, when we have the bool constructor, the bool constructor returns false. So when you're using a default dict, which is in collections, import default dict, and you instantiate it with a bool, then well, that doesn't make any sense. Let's say this dict that's what we'll call it, this dict. Then actually what happens is that, yeah, so basically what happens in this case is that the anytime we ask this dict, so this dict is empty first off, all right, as we can see over there. So but if we were to say this dict at a, let's call it that, it will return to us false. And basically it's just going to use like the default return value of the constructor as the return type of when we try to access a key value pair that doesn't exist. But if we check right now, yes, a actually does exist and has the value false. So when we start with 1, it will have the value false. We'll check if skip index is num, it's going to be, well, it's not there and it's going to return false anyway. So false, so we enter over here, we append 1 to the stack, then we say append 1 to the stack and we mark this as seen. All right, so I'm just going to, for the sake of ease, I'm just going to say seen equals to 1. All right, just for the sake of ease, we'll pretend that's not a dictionary. Anyway, next thing, you just go over here and we traverse, you see? So we enter the loop again, and then we'll ask for 1. If skip indexes is 1 equals to true, pass. Yes, we've seen it, so we pass. That means we go to 2 in the loop. So next thing we're going to do is add 1, 2. And then we're going to call traverse again. And then the next thing, we'll in the loop for 1, for 2, because we've seen both of them. Yes. We'll say, okay, we've seen them. So for 3, we'll enter, then we're going to call traverse here. All right. So 1, 2, 3. Great. Now we're going to call traverse again. Still, I'm running out of space here, it seems. I don't know how to create more space. But we're going to call traverse again. But now we've seen all of them, so we'll just say for 1. Have we seen 1? Yes. Have we seen 2? Yes. Have we seen 3? Sorry, 3 would be the last one. Have we seen 3? Yeah, we've seen all 3 of them. So let's move on to the next one. And now what's going to happen over here is we'll go to the bottom and we're going to return. All right, so we're going to return from here. We're going to return from sorry. So we'll go down and so the first thing that will happen is we'll check is the length of stack equals to length of nums. So now we see that we have 3. So at this point we're going to add it to the solutions. Sol equals to 1, 2, 3, and we're going to return. Yes. All right. Then we're over here. There's nothing left. We've added all 3. We've also gone through the whole loop. So there's nothing to do apart from return at the end of the loop. And then we're at 1, 2. And at 1, 2, there is something to do because we're in the loop at 2, but there's still 3. So we'll just go ahead and we already popped. That's what we just did. And we set it to false, which is here. We set that to false, and yeah, so sorry, that was a bit confusing. So now all we're going to do is go to 3 next, and we also popped 2 over here. We also popped 2 from scene. We popped 2 from here. So actually, we do go up a point more. And then over here, we ask ourselves, is there something else we can do? And yes, we can do 3. So we go to 3. All right, a 1, 3, and so on and so forth. I think I've really talked about this ad nauseum at this point. Hello. I've really talked about this ad nauseum at this point. So yeah, let me just go ahead and see like the next. Let's move on to the next part. So what is actually the bug? I'm going to pretend. I'm going to stop pretending there's like a million people watching this. What is the next bug? I'd just like to get ahead like with the actual new one at this point, you know. Yeah, anyway, what's the next bug? So actually the bug over here is right here, and it's very sneaky. Like I kind of like went over it like pretty quickly, but because we do this over here, we don't properly copy stack. And so what happens, we have this pointer to stack basically, and yeah, we can just have a look at this. All right, so if we have a list, let's call it A. All right, we do this. Then we have a list called B. We do this, and we say B is equals to A. So, and then we say B dot append 1, and then we print out B. We see that B has 1 in it, but what happens? A also has 1 in it, because we didn't actually make a copy anywhere. We just made an assignment, and that means A and B point at the same value, and that's the problem here. So the logic itself is sound, apart from the fact that we don't make a copy over here. Because we don't make a copy over here, the same stack that we're going to change still, we're going to go and we're going to change it here, we're going to change it here, and so on, and then we're going to go down, and then we're going to go back up all the way to this empty one. That is going to be copied multiple times, and at the end it's going to be empty. So actually what happens when we look at our bug, we see that we have exactly the same issue. Over here we have 1, 2, 3, 4, 5, 6. We have 6 empty arrays, 6 empty lists, that is. And over here we also had 6 lists that should have been in the output. So our problem was literally just that we didn't make a proper copy. So this is easy to fix, very easy to fix. We can just do sol equals to sol plus stack dot copy. All right, and boom, we've gotten it. Now bonus question time. What are the redundancies in the following code? I'll give you all a moment to ponder. All right, so there are multiple redundancies over here. First off, let's start off with I'd say maybe the most obvious over here. So yes, so over here there's no need for us to do this. I guess it should be, and we are creating a new list object over here, but there's no need for us to do this. We're creating a new list object, then assigning that its value to sol. But there's no reason for us to do this. We can just mutate sol in place, right? That's the first, right? And yeah, that's much better. And many of you may be asking something that I missed, I just didn't explain. All right, Kenna, why do we use copy? Why don't we use deep copy? Wouldn't deep copy be more appropriate? And I hear you, and in some ways you are actually right. You are actually right. But as we can see in the documentation over here, if we go to the copy module and we scroll down to deep copy right over here, the difference between shallow and deep copying is only relevant for compound objects, objects that contain other objects like lists or class instances. So, well, I guess maybe that's a bit confusing because in Python everything is an object. But the thing is that integers, strings, tuples are immutable. So when we create a copy, regardless of when we create a copy, these items are copied anyway. Because they're immutable, we can't create how's a good way to explain this? Let me think about it. Okay, no, that would be a bit different if we had like a tuple with a list inside. But it can get a bit complicated, to be fair. But the way you have to think about this is because let's think how do I say think about this? How can we think about this? Okay, I don't have a good analogy at the moment, to be fair. But what you can notice, I'll just show it in practice then. So if we have this list, that's 1, 2, 3, and B is A, then actually we've just done an assignment over here. Yeah, we've just done an assignment over here. So if we change anything in B at 0 equals to 0, it will also change in A. Alright? But if we do this, b.copy, b equals to a.copy. And now we say b0 equals to 0. And now or b0 equals to 1. Let's switch it back, alright? And now we ask ourselves, what is A? A is still 0. And what happened here? So we used copy first off, but copy actually only changes the container. So if actually something that we can do still, even if B and A are, or something that we, how would I put this? Something that we could do, let's look at this example. And B equals to A. And we say B equals to A.copy. And then we say B at 0 equals to 0, like that. So what do you think is going to happen with A? Place your bets. So, let's see. A doesn't change. B at 0 equals to okay. Yeah, okay. Yeah, I'm sorry. I know exactly what I did wrong. So let's go to B at 1, right? B at 1 at 0 equals to 0. Right. And now A. And now B. Okay, yeah. So we actually see that the reference of the object that is within the list, well, it's the same objects that's shared between the lists. So when we change that object, it changes in both lists. But as we said, like strings or integers and tuples, they're all immutable, so they can't be changed. So I definitely need a better explanation for why this is the case, but so when you copy, they won't be changed. All right. So let's get back to this. So there's still how many redundancies? So there's still 2 redundancies over here. Can you find them? There are 3 redundancies in this code. Let me go back, and then I'm going to use that as a clip for sure. There are 3 redundancies in this code. Can you find them? Great. Okay, so there are 3 redundancies in this code. Can you find them? There are 3 redundancies in this code. Can you find them? Alright, that should be pretty good. Okay, so let's look at all of this. Yeah, so we had fixed this redundancy over here. Solve.append stack.copy. So yeah, back to the copies. A deep copy would also copy everything recursively. So it would copy the other containers, and yeah, and so we'd have like a new unique object where they don't share any references to any data between them. Yeah, so I'll reveal to you what the redundancy is, but it's a sneaky redundancy. So can you tell me? Can you tell me why in this piece of code the non-local stack is redundant, but the non-local sol has to be there? Well, the reason why it's that way is because we do a reassignment for sol. So if we remove this over here, we get an error. But if we don't remove it and we remove stack, and remove stack, we don't get an error. Actually, wait a second. What is up? What is up? Non equals to sol stack but copy. Copy. Sol equals to sol and sol plus wait sol yeah, sorry, yeah, so we see that it actually works with this one. Yeah, sorry, I made a little mistake over there. So if we remove the so if we're using append, of course append just emits none, so we don't need to assign it. We're assigning the none to sol, so we had a bug there. So let's continue looking. What else is there here? Yeah, so we've removed that redundancy, and as you see, we remove stack, everything is fine. But if we remove sol, well, now there is no issue. Why? Why is there no issue this time around? Because we're not doing any assignment anymore. We're only doing mutation. We're only mutating it, and you know it's really tricky, like that distinction. It definitely caught me a couple of times. Okay. Anyway, that's what I had like for today. You know, and I think I've spent like long enough on that topic. I wanted it to be a bit more interactive, you know, with me and like chat, but it seems like getting an audience is a little bit more difficult than expected. But hey, you know, all's well that ends well. So yeah, let's go to the next one. And I guess now this time around, I have no excuse for failing this. Okay, you're given an array nums of integers which may contain duplicates. And I can also just show the timer. Okay. And we'll give ourselves 20 minutes for it. That should be good. Okay. I'll put that up there. Yeah, why not? Right there. Good. Okay. Okay. And let's see. You're given an array nums of integers which may contain duplicates. Return all possible subsets. Subsets including the thing itself. Okay. And this is essentially, I'm just going to say save myself some time. No, I'm not going to save myself some time. This is very similar to the previous problem. So let me just, I'd usually save myself some time to be honest. And just like copy the code, then just change it where I see that I need to change it. But I guess it's also fine to try just doing it from scratch. Nums, list of integers. No, we don't even need that. So we have the stack, and this, and we traverse it. And let me just try. So I can have the sol just be a, what do you call it, tuple. Then I don't even have to worry about duplicates. I'll just transform it to a list in the end. So I mean, to enforce this, we could also just sort it just to the start. Then we'll have everything that's it from in ascending fashion. That means the only like duplicates we could get would be between numbers of the same, like the same number, that is. So I mean, we can check the time complexity. Yeah. So that sort is, well, I didn't really need to do that, to be honest, but that sort is not going to hurt, basically, was my thought. That was my thought process. Okay. Because the subset 1, 1, 2 is the same as the subset 1, 2, 1. Right? Oh wait. Yeah, there's no order over sets. Like per definition, over sets there's no over order. It's over sequences, which there's an order. So order should not matter. If order did matter, then we'd have 2, 1 over here also. So yeah, okay. Let's see. Different order doesn't matter. For I nums, what am I doing? For I nums. Yeah, you know what, I can just do a very, very similar solution, really. C equals to default boolean. If I and C, we say, if we've seen it before. I see, that is a problem. So I would want to, I guess I can enumerate, and then for I, nums, I could say save it as this. Now this is just go off of index, I guess. If we've seen the index before, yeah, I mean we can just go off of index actually. If I and seen, you just pass. Although I don't think the time complexity should even be that bad. Yeah, I'm doing some redundancy, like somewhere over here. This would be n factorial if I continue doing this way, and that's quite bad. Okay, I see it. So we can do some pruning for sure. We can do some pruning. So the thing is, if a certain like prefix already exists, well, okay, if I and seen pass, else stack dot append append if tuple stack tuple stack in, so I'm changing it to a tuple because lists aren't hashable. So yes, if tuple stack in sol return. Continue actually. Else, well, we just continue with the next stack.pop. Continue. Else we say seen at Scene at now I. That's so weird. Stack that append nums. Thank you very much. Scene at I equals to what's up? Scene at I would then be equals to true. Well, actually, we don't need the else. We'll just have this. This looks better that way. Scene at I equals to 2. And we'll call traverse again. Right. And yep. And then once we're done with that, it's just the same thing. Stack.pop. Stack.pop. And what else? Stack.pop, and we also have to make it unseen again, right? So scene at I equals to false. Okay. And also over here we return. Okay. I don't think this is like the. I do think that there's this slightly different way of doing it. That's better. So we'll just say at the stack, when you call traverse, we always copy whatever there is, right? If that makes sense. Traverse equals to traverse. Dot append, not soul dot append, soul dot add, stack dot copy. Oh no, we don't need to copy it anyway. We'll copy it anyway by doing this, right? Triple stack. Then we convert this back to list I okay. So then I feel alright with that, but I think let's check it out. What's the problem over here? Tuple object has no attribute add. What am I doing? Yeah, I'm not thinking about a tuple, I'm thinking about a set. Yes, okay. For I, nums and enumerate nums cannot access local Yeah. Non-local nums. Isn't that it? Int object is not iterable. Int object is not iterable, yeah, sure. Int object is not iterable. When do I try and iterate over an integer? Nums is a list of integers. Non-local nums, okay, yeah, that looks good to me. And then it's empty, and I say for I, nums and enumerate. For I, num, maybe that's probably it. Yeah, what do I get? 1, 1, 1, 1, 2, 1, 1, 2. So that's all good. And 1 and 2. So I do get 1, but I don't get 2. I see over here. So why don't I get 2? Let's see. So we'd enter 1, then we'd call it, then we'd do everything that has to do with 1. Alright, and then we'd say we'd come back up and say stack.pop. We'll remove 1 from the stack, and then we set that. Let's try and look at what's going on. So we add that. We enter the function. We add the empty one, and then we add tuple stack. That means we add the empty tuple. We'll convert everything at the end, so I'll just pretend that that's the tuple. And for I and nums is 1 to 1. 1.2,1. Then we say for I and ones, so it's going to be 0,1. Right? If I and scene, 0 and scene, pass, no. Scene is empty. I'll also just put that down as an array for now. If I and scene is empty, 0, 1, pass. Else stack.append num, yeah. If tuple stack in sol, if 1 in sol, stack.pop, nope, sol is still, I should have totally marked that too. Else continue, or stack.pop continue, else scene at 1 equals to scene at 0 equals to true. Okay. Traverse again. Alright. Non-local nums. Sol.add tuple stack. Yes. That looks good to me. It's somewhere over here. Somewhere over there. I have it here. So yeah, I can add 1 over here, and now that's how we look. And then I say I go back in. This is why I love paper. It's so much easier to do stuff on paper, like sketch out the whole traversal. If I in scene pass, I'm running out of time. But I just have to do this. This is the reason why I should. So we start with 1, we go to 2. We say, is it seen? No. So we add that to the stack. So our stack is now stack equals to 1, 2. And another stack is 1, 2. We go to the next thing. 1, 2 is not in sol. So we set scene at 1, yeah. So scene I just need to try some stuff out. I know that it shouldn't actually be needed over here. Okay, for sol for sure not. But I'm just failing this for no reason. If I run this, I pass this obviously. But I don't pass it here. Why? Because I'll go 1. Because I sort the stuff at the start, so it's 1, 1, 2. Actually, what I do want to be accurate about that, specific about that. Then I'll go to 1, 1. Let's say 0, 1. And we haven't seen that before. So we'll set that to true, and then we'll traverse, we'll get over here, then we have 1 empty, and then from this point we're going to, okay, I'll give myself like 5 more minutes. I don't know, I feel like I'm so close actually. I feel like I'm so close, and I don't know where my bug is, or at least I'm not close to the optimum solution. But I mean, 20 minutes is not even that bad for this, to be honest. But I just don't know where my mistake is, and that's anyway. So we see this, we add it, then we call traverse again, and we've seen 1, 2. So the last thing we do is 2. So we're going to say scene 0 and 1, 2, and our stack is 1, 1, 2. Just to be clear, 1, 1, 2. And scene is 0, 1, 2. Then what do we do from this point on? Scene is 0, 1, 2. Now from this point on we go, we call it again. Okay, and now we add 1, 1, 2 to it. Alright. Or rather, we didn't need to do that. Add this to it. Okay, so that's where we are. And then we say for inums, we enumerate over all of them. We don't get any of them. We say return. Okay, so we just return. That's all we do. We return. So we're back over here after having have said that. Let's say, to be more correct, we would have had this, then this. Then we stack pop, and let me just be completely accurate about the order of this stuff. What am I doing? It is exactly this way. That's how it happened, right? We added it to scene. No, yeah, we added stack and scene, then we did that. Stack scene. Okay. So at this point we say scene 0, 1, and we say scene at 2 equals to false. Okay. But now we're done with this one. So we go back. Oh, this is so annoying. Oh, if it was an obvious bug, I'd know where to start, but now all I can do is like traverse it by hand, and that's it. So much work. Scene at 0, 1. Scene. Right, and then we go, so we return. So we go back, where was it? We go back to here. Alright. And we say scene is 0. I'm not going to put in all the intermediary steps. That's just a whole lot of work for nothing. Not for nothing, but I'm just like really bored at the moment. And kind of pissed off. Not kind of pissed off. If tuple stack in solution, I just need to think this through. How much time do I have still? Damn, time flies. Alright, we might have to throw the towel in a moment. Let's see. So we appended to the stack. So the question is, why does it never get to the point where 2 is just alone? That's what I don't get at all. Why do we never get there? That's the question we're trying to solve. Oh, we also don't have 1, 2. That is interesting. I didn't see that before. We don't have 2. We don't have 1, 2. So 1, 2 we should have had. No, wait. So we go 1, 1, 2. Okay, I think I'm getting somewhere at least. So I should actually just come back over here. I was so close to actually seeing what the problem was, but then I stopped just debugging like this. Okay, scene 1 was turned to false. Scene 0, that means we go to the next one, which is 2. Scene 0, now we're 2. If I in scene, if 2 in scene, 2 is not in scene. Let's start the depend now. Damn, I don't see it. I throw in the towel, and I'm going to ask. I know I'm so close. And let me ask my good friend ChatGPT what I'm doing wrong over here. Where's my bug? I know you know where it is. I feel like I was close at least, And I think that, if I have to say where I think the bug is, it's definitely over here. But I think my brain is kind of it's kind of fried at the moment. So I'm I am kind of. Oh my gosh, I see the problem. Well, ChatGPT has shown it to me, but then I see the problem. It's so stupid. It's so stupid because it's because it was that. That must be the problem, right? If seen at I, okay. Okay, so it was part of the problem. It was part of the problem because, I was checking if it's there, but then as we just saw, I just added to the list. If I add something to the dictionary, so where did we just had it over here? Now it is in the dictionary. So if I ask if is A in the dictionary, then it's going to tell me true. So that was a big problem that I had. But it seems that I still have another bug still, and it seems that I'm still traversing everything. But it seems I still have an issue. Okay, that's also useless. I don't know why I'm doing that. Why am I? And then just let's see what GPT says about this. Oh no, sorry, I just deleted something that is right. Start to append num scene I. So it will see the index. Well, it's actually continue. Well, it ends up being the same thing, but that's just more correct for the code perspective. Yes. Then what else? Where is my problem? So that add that sound. Yeah, I knew this was unnecessary. I was just like, I didn't understand where my problem is. Okay. 1 2 1 1 2 1 1 2. So I still don't have to. Okay, I'm completely lost. Let me ask ChatGPT what's going on. Well, I think I tried my best there. Hey. My brain is a bit too fried to try and do this like right now. And I need to leave soon. It's streaming for an hour. Damn. Damn, yeah, where did I go wrong? If I'm always stopping early, if I'm sorting, or did I remove the sort somewhere? No, I am sorting, so how is this even possible that I have 1 2 1? I have no idea. Like sorting is an integral part of it, but I just don't. I don't understand what. Because sort is in place. Sort is in place. List and sort. So in place. Okay. Okay. I'm trying to see where my errors first, you know. The new models take like a long time to think. So let's just see what I got wrong. Mm. Okay, so I've seen like a couple of my bugs. I haven't like really looked at the answer. So probably like tomorrow morning I'll try and figure that out. But yeah, I guess one of my problems is that I'm sorting it, but then I'm using the index, so that's why I still get like all of these issues. I'll look at that tomorrow. I have other stuff to do today. I want to snack something too. So yeah, thanks for watching. Like for the guys who watched for a while, and I'll see you tomorrow with what we're doing tomorrow. We'll probably do generate in that word search. Maybe we'll do that tomorrow. See you.